The strangest thing about Artemis 3 is that after Artemis 2 successfully carried astronauts around the moon and back, NASA's next mission is no longer the mission that puts boots on the lunar surface. Artemis 3 is now planned as a 2027 test flight in low Earth orbit. The first Artemis landing has been pushed to Artemis 4 targeted for early 2028. That sounds like hesitation. It is actually something more revealing. NASA has the rocket. It has Orion. Artemis 2 proved the basic system can leave Earth's swing around the moon, survive re-entry, and come home. But a moon landing is no longer controlled by NASA alone. It now depends on commercial landers from SpaceX and Blue Origin on docking systems, life support, propulsion checks, new lunar suits, and technology that still has to work together in orbit before anyone risks trying it over the far side of the moon. And that changes the meaning of Artemis 3. This is not the triumphant, final step people expected after Artemis 2. It is the moment NASA admits that returning to the moon is no longer a single launch or a single spacecraft or even a single institution. It is a race between two industrial systems, both incomplete, both expensive, both carrying the weight of American prestige. The real question is no longer whether NASA can reach the moon. The question is, what actually has to happen before it is safe to try? Most people still picture Artemis as Apollo with better software. One rocket, one crew. A clean arc from Earth to lunar orbit to the surface. But that picture is already obsolete. NASA's current architecture is messier, more modern, and much harder to control. Artemis 3 is now a low Earth orbit demonstration mission in 2027, not the landing itself. And the first crewed lunar landing has moved to Artemis 4 in early 2028. That shift matters because it reveals what people usually miss. Artemis is not one spacecraft going to the moon. It is a chain of systems that only works if every link survives contact with reality. NASA provides SLS and Orion. But the vehicle that actually takes astronauts down to the lunar surface is commercial. Right now, that means landers being developed by SpaceX and Blue Origin, with Artemis 3 specifically intended to test rendezvous docking and operations with one or both of them, before anyone bets a human life on a descent over the lunar South Pole. And the lander is only part of it. The suits are new too. NASA's lunar surface suit is being built by Axiom Space, and as of early 2026, it was still moving through major technical reviews and test milestones. That means the first return to the moon is no longer a single technological achievement. It is a synchronized performance between rockets, capsules, landers, docking hardware, life support systems, and suits, all built by different organizations, all on different timelines, all expected to work together in vacuum. So the popular version of Artemis gets the most important part wrong. The challenge is not just getting astronauts back to the moon. It is proving that an entire industrial ecosystem can hold itself together long enough to do it safely. And that is where the first real wall appears. Not distance, not courage, fuel. The first real wall is not the moon. It is orbit. Before Artemis 3 can prove anything useful, at least one commercial lander has to be waiting there alive, fueled, stable, and ready to accept a crew. That sounds procedural. It is not. For Starship's lunar architecture, NASA's Inspector General says the system depends on putting a propellant depot in low Earth orbit, then sending more than 10 tanker flights to fill it, followed by a large vehicle-to-vehicle cryogenic transfer test that NASA considers one of the program's most significant technical challenges. This is where the romance falls away. These are not ordinary fuels. They are cryogenic propellants stored at brutally low temperatures, and long-duration exploration depends on being able to store them, measure them, and move them without losing control of the system. On Earth, gravity helps. In orbit, it does not. The propellant does not behave the way engineers instinctively want it to, and NASA's own watchdog notes that the technologies and processes required for this kind of vehicle-to-vehicle transfer have never been done before in this form. And the scale is unforgiving. A delay here is not just a delay. It can break the sequence. NASA has already warned that even the planned launch cadence needed to build up propellant in orbit may be hard to sustain, which means every missed turnaround starts eating into the mission before Orion ever leaves the pad. That is why Artemis 3 was pulled back to Earth orbit. Not because the moon got farther away, but because the machinery required to reach it safely is still being taught how to exist. And this is where the mission stops, looking like exploration, and starts looking like systems integration. NASA is not building every critical element itself. For the landers, it is buying services through firm fixed-price contracts, while giving SpaceX and Blue Origin significant latitude in how they manage development with fewer agency-required reviews than a traditional NASA program. That can move faster. It can also hide trouble longer. And if something slips, the public still sees one logo on the mission patch. NASA's Inspector General says the agency has already obligated $6.9 billion to the Human Landing System program and expects that figure to reach $18.3 billion through 2030. Then, there is the layer most people never see: interfaces. A moon mission does not fail only when a rocket explodes. It can fail when two perfectly good systems do not quite fit together. NASA's own watchdog says Collins dropped out of the next-generation spacesuit effort, leaving Axiom as the only active provider, and formally recommended that NASA create a plan for interoperability standards between Artemis lunar vehicles and spacesuits. In other words, the suit, the hatch, the controls, the umbilicals, the procedures, and the emergency logic all have to agree before a human being can safely step outside. That is an inference from the interoperability problem NASA itself acknowledges. So the deeper system is not one machine. It is an argument between timelines. The lander has to mature. The suit has to mature. Orion has to meet it. Operations teams have to certify the choreography. Artemis 3 exists because NASA no longer wants to discover these mismatches in lunar orbit 3 days from Earth with nowhere to go. And that caution is not weakness. It is what reality looks like when ambition finally meets the paperwork of survival. This is why Artemis 3 matters far beyond one mission patch. The lunar South Pole is not just another landing site. NASA is targeting it because ancient rocks trapped volatiles and possible water ice. There could answer major questions about the moon's history and the early solar system, while also pointing towards something more practical: resources that future crews may be able to use, rather than carry all the way from Earth. That makes Artemis different from Apollo. Apollo proved you could reach the moon. Artemis is trying to prove you can start staying there. And the consequence is bigger than science. NASA describes Artemis as the foundation for a sustained lunar presence, a path to Mars, and part of an expanding space economy built with commercial partners and international agreements. The Artemis Accords now have 62 signatories, which means the moon is no longer just a destination. It is becoming a place where rules, standards, access, and influence are being written in real time. Artemis 3 is one of the missions that decides whether the United States remains the system builder at the center of that order. That is also why delay has a cost, even when nobody crashes. China is aiming for a crewed lunar landing by 2030, while the U.S. is trying to turn Artemis into a durable architecture before that window closes. So the meaning of Artemis 3 is not simply whether astronauts can dock with a lander in Earth orbit. It is whether NASA can turn a fragile coalition of rockets, contractors, and schedules into something stable enough to matter before the moon becomes crowded, divided, and harder to define on American terms. So what will actually happen on Artemis 3? If NASA's current plan holds, 4 astronauts will ride Orion into low Earth orbit in 2027 and spend the mission doing something less cinematic, but far more important than a lunar landing. They will test whether Orion can meet a commercial lander in space dock, with it move into it, verify its life support communications and propulsion, and prove that the systems meant to carry humans down to the moon are not just impressive on paper, but survivable in operation. Artemis 3 is no longer the return to the surface. It is the moment NASA decides whether the return is real. That is a quieter mission than people expected. It is also a more honest one. Because the moon was never the hard part, in the way people think. The hard part is building a chain of machines, company standards, schedules, and human bodies that can cross 250,000 miles without one weak link, turning ambition into an obituary. Artemis 3 is what happens when a space program stops pretending that courage can substitute for integration. It is a rehearsal, but not a symbolic one. It is the rehearsal that decides whether Artemis 4 gets to become history at all. And that may be the most revealing thing about this entire era of exploration. Apollo looked fast because it was willing to accept enormous risk. Artemis looks slow because it is trying to build permanence. Not a visit, not a flag. A system. And systems are colder than myths. They move at the speed of fuel, transfer hardware, interfaces, budget lines, and failure reports. So when Artemis 3 finally flies, the real drama will not be a footprint in lunar dust. It will be whether humanity has learned how to deserve the next one.